This is question number 1 of paper 3, May 2023. And so we're told in this question you will be investigating the family of functions of the form f of x equal to x n to the times e to the power of negative x. And we're told the following function. When n equal to 1, the function is, sketch the graph of y equal to f of f1 of x. Alright, so this is relatively easy. You just go into your GDC, right? And then the function is x e to the power of negative, where's negative? Negative x. Sorry. X e to the power of negative x. Come on, man, what is going on? X, okay, I see. Where are you? Okay, there we go. Alright, so this is your function. Now, we're told that the domain is starting from x greater than or equal to 0, so I'm going to change the window zoom setting from 0 to 10. And so you have your maximum point. You can use the intersect option and then find it and then graph it. Alright, show that the area of the region bounded by the graph is given by, so the area is from the integral of 0 to b, right, of x times e to the power of negative x dx. Now you can use integration by parts, but I like to use the table method for this, much quicker. So the 0 plus minus plus e to the power of negative x negative of negative x. Now I'm not going to explain how this works. I will, if you're interested to learn more, you can search it up. I believe Stanford University had an article on this. I'm not sure though. Alright, so x e to the power of negative x times e to the power of negative x times e to the power of negative x, right? And from b to 0. So now if you substitute in the values, negative b over e to the power of b minus 1 over e to the power of b, and then we have e to the power of 0 as well, so this will become 0 if you substitute in 0. This will become 1, so minus 1. Now if you find the common denominator, it'll be negative b minus 1 minus e to the power of b over e to the power of b, which is, where did I make a mistake? I'm sorry, this is going to be plus. Okay, there we go. That's right. Alright, part C. Let me just snip this quickly. Okay, we're told that you may assume that the total area of the region between the graph and the x, alright, and is given by the limit. Okay, so use L'Hopital to find, that's easy. So L'Hopital as b approaches to infinity. So you have to take the derivative of the numerator, which will be b eb minus b over beb, right? Now if you substitute in infinity, it will still be indeterminate, so you gotta take the derivative a second time. So b squared e to the power of b minus 1 over b squared eb, right? I feel like I have made a mistake. Oh yeah, this is minus 1. This will be, now you can cancel out top and bottom, and so the limit of b infinite is 1, so it's equal to 1. Hence write down the value of a, so that's easy. A1 will simply equal to 1. Now part D, you're given that A2 is equal to 2 and A3 is equal to 6. Use your GDC and an appropriate value for your upper limit to determine. So I personally solve this by how do I solve it? Okay, so I went in my GDC, and we know that the f4 will be x to the power of 4 e to the power of negative x, right? E to the power of negative x. So I substituted in this function in my GDC, and I got this graph, right? So I came to the integral, and then chose the graph for this f4, and then lower bound 0, and then boom. So now what you can do is you can actually increase the zoom as well to, like, let's say 100, and you'll see that the area underneath the graph is simply equal to 24. Now a5 will be, so again, the same approach. So x to the power of 5 e to the power of negative x. Now you go 6, then graph, you'll choose the graph of f5, and then drag this, that'll be 120. So a5 is 120. Now in part E, we're asked to suggest an expression for an in terms of n. Alright, so well, if you pay close attention, you'll see that an is simply n factorial, right? So that's it. Okay. Now, the best part of the question: use mathematical induction to prove your conjecture from part B. Prove your conjecture from part B. So as you can see, the previous steps were relatively easy, and so this last step is worth 8 marks. The whole thing is worth 25 marks. So previous steps were just a piece of cake. You just gotta solve this last big boss. Okay, so we got our statement here. We want to prove this using mathematical induction. I'm sorry, what sound is that? Oh, it's from my iPad. Anyways, so we want to prove this, but we also know that the integral, this is equal to the integral of fn of x dx from I don't know, from 0 to infinity, I think. Yeah. So when n is equal to 1, your a1 is equal to 1, and that is true. We solved that earlier. When n equal to k, when n equal to k, your area underneath the graph will be k factorial. But you can also, I guess it is better if you also write in terms of the integral as well. So it's going to be x to the power of k e to the power of negative x dx, right? So this is equal to k factorial. Now when n equal to k plus 1, it's going to be a k plus 1, the integral of I'm sorry, give me a second, let my mind load. So the integral of x to the power of k plus 1 e to the power of negative x dx, right? And so now it should be pretty obvious. So let's consider this as our left hand side, and our goal is to reach this fucking statement. Yeah, so your goal is to reach k plus 1 factorial, and there's no excuses for this, you motherfucker. So this isn't PG, but alright, let's see. So you can solve this using integration by parts. I'm gonna consider x as u. So u equal to x to the power of k plus 1. So the du over dx will be k plus 1 x to the power of k, right? And your dv over dx will be e to the power of negative x, and so your v will be negative e to the power of negative x. So solving by integration by parts, it's going to be negative x to the power of k plus 1 e to the power of negative x. Let me just check. Yeah, I'm doing this correctly. And so this will be from 0 to infinity, right, minus the integral of what? So v, yeah, so this will be plus, and then we have our du as k plus 1, so I'm gonna bring that out as well. So k plus 1, the integral of e to the power of negative x, x to the power of k dx, right? Okay, yeah, so now it should be pretty clear, right? And no excuses, man, no excuses. You should clearly see that this thing right here goes into this thing right here. It goes into here, right? I'm trying to make the classes more interactive and fun, so I'm going to use personal slurs. No, not racial slurs. I mean, I'm gonna try to make it more interesting. So if this goes from 0 to infinity, it'll simply be 0, right? Yeah, so this will be 0. I'm gonna cancel that out. Then k plus 1, the integral of, and so that is, we found that to be equal to k factorial. So k plus 1 times k factorial is simply k plus 1 factorial. So that should be pretty obvious for you. And now you just solve these statements. So you'll end this by saying, therefore, by proof of induction, I don't know, we found that it is true for n equal to k plus 1, then it must be true for all positive values of n, positive integer values of n. And so yeah, that's all for question number 1 of May 2023. I think this was, I'm not sure about the time zone, but yeah.